All right, we're in geometry. We're on lesson 4-4. Today is Friday. Today's date is the 11th, 1/11. All right, make sure your name and date are on your paper just in case you lose your notes. I'm talking to the boys in this general area over here. All right, so angle bisector theorem. So I'm going to just tell us what the theorem is. If you want to see a proof, the proof is going to be on the back. We're going to be going over that shortly. All right, so if I look at okay, so we assume that this angle and this angle happen to be the same. So this angle and this angle are congruent. That means that AC, if I divide AC by CD, these parts of the triangle here and here, if I divide them, they're the same ratio as this angle or this length divided by this length. That's our formula. Don't wear it out. Or maybe you do want to wear it out. All right, example 1. See if you can utilize the formula. I'm going to be doing number 1 with you. You're going to be doing number 2 in your groups. So let's do this. I'm assuming the same thing. So if these two angles are the same, they are congruent. So I need to find the length of this missing segment. What is this segment? So I'm going to copy down the formula. The formula says AC over CD. AC is 3.4. Copy it down. 3.4. That's unnecessary, Jaden. 3.4 over CD. CD is 2.8. All over 2.8.
You got a formula there, boss?
Someone else do the next part. What length goes on the top right? Quiet raised hand. Beverly. 4.1. Beverly, turn in your participation card. You got some XP. And on the bottom, I have what? Chewy.
Is that going to be like X or something?
Yeah, it'll be X. Or you could do question mark. X is even better because that's going to be our algebra. Thank you, Chewy. You have your participation card in. All right, what is my next step? Whenever I have two fractions set equal to each other, you're going to be doing what, Anna? Cross multiply. So Anna, thank you. Turn in your card. India, help me by setting up the left-hand side of my equation. Which two are you going to do first? Are you going to do 2.8 and 4.1 or X and 3.4?
For me, I first put 3.4x on the right side because I didn't have to do any multiplication.
All right. 3.4x. Thank you, India. You can turn in your card. We'll let someone else do the left-hand side. What's the left-hand side going to be equal to? Left-hand side is going to be equal to what, Samantha? 11.48. Nice. You will be needing a calculator for the homework, and that's by cross-multiplying 4.1 by 2.8. Let's just check her work. 4.1 times 2.8. We believe her, just so everyone else can see. We just multiplied those two numbers. We got 11.48. All right. Next step is to do what? Hold on. I think I forgot to give Samantha her XP. Can't forget that. Next step is to do what, Ellery? Divide both sides by 3.4. Divide both sides by 3.4. Ellery, do you happen to have that offhand, or should we do this with a calculator? 11.48 divided by 3.4. And it says round to one decimal place. So round that correctly for us, Ellery, please. 3.4. Yeah, we're rounding to this decimal place. 3.4. So x is equal to 3.4, which is actually what we divide by, strangely enough. That's our final answer. We box it. You box it. Ellery gets her XP and turn in her card. All right, any questions about example 1? Chewy, Hood.
Are all the problems going to be like this?
All the problems are going to be like that. I'm just going to move that question mark to one of those 4 spots, and I'm going to rotate this triangle around like I did down here so that it's a little bit harder to see. Questions, questions, questions? All right, I want you to work by yourself and with your group to do example 2, and then I'm going to come back and do that with you guys. All right, so example 2. Jaden, you lost HP. So example 2, how do we do this? Thank you, Jaden. Participate. Go for it.
It's on my card. Okay, want me to start with the first step?
Yes, please.
Okay. 5.4 over 5.1.
0.4 over 5.1 is equal to?
X over 4.3.
X over 4.3. There it is. Turn in your participation card. Thank you, Jaden.
Don't read it. Apparently. That's not fair.
We'll just do language. Colby, you're going to protect. You get some XP. All right. So from there, What is my next step, Loria? 23.22, like that. Yeah, there it is. Thank you, Loria. Turn in your card. And just to check that with our calculator, 4.3 times 5.4, 23.22. Very nice. And next step, quite raise hand with someone that has a card still. Colby.
Divide both sides by 5.1.
And what do you get, Colby?
4.6.
4.6 rounding to the correct decimal place. Let's check that on our calculator as well. 23.22 divided by 5.1, 4.6. Yeah, we round that up because it's 5 or greater. So that is the final answer, and we box it. I'll go back and give you, whoa, I don't want a square, I want a rectangle. Please.
Oh, what is this?
And Colby gets his XP. All right. So on the back, I want to go through this really quickly. Why is the angle bisector theorem true? I could have made you do the proof by hand. I decided to do it for you with some really nice pictures.
This isn't gonna be on the homework.
This is not going to be on the homework. I just want to make sure that we understand where this comes from. All right, so given that we have these two angles the same, somehow we need to prove that that proportion is the same. How can we do that? The first thing that I do is I extend this line out, and then I make this line, I'm going to make a parallel line that goes through B right here to get this shape. So now this line, BE, is parallel to this line segment AC, and I still have this extended line. So by alternate interior angles, this angle and this angle are the same. Nod your heads if you're following. Uh-oh, Chewy, are you following? You're good. Oscar, you're following? Good. From there, we know that these angles right here are the same by vertical angles. Nod your heads if you follow. Ah, there's all the nodding heads. It's like a bunch of bobbleheads. It's really cool. All right, this blue triangle and this red triangle are the same, or not the same, they are similar because angle-angle theorem. Angle-angle theorem says if you have two of the same angle, this theta and this theta are the same, this phi and this phi are the same, then those two triangles must be similar, using this symbol saying similar. We can all nod our heads. We agree this to be true. From there, I can say, well, AC over CD is equal to EB over BD because they are similar triangles. Nod our heads. Are we following? Brian, are you okay? So far, so good? Okay. Triangle ABE is isosceles because these two base angles are the same. If base angles are the same, it has to be an isosceles triangle. Nod our heads if we follow. That means that AB and BE, or EB, are congruent. They are the same length because it's an isosceles triangle. So far, so good. Nod our heads. Uh-oh, that was a harder step. Apparently, not as many people nod our heads. Now we're starting to get it. Therefore, since this angle, or this length and this length are the same, I can now change EB to AB since AB and EB are the same, and thus I have proven AC over CD equals AB over BD. Nod our heads. There's a proof. Oscar, are you okay? No? I can come talk to you after the lesson if we want. But there is your proof of the angle bisector theorem. Go ahead and write your summary now. After you finish your summary, you may begin on the homework assignment either on paper or on Khan Academy.